So in the first of these quick tutorials, I showed you this sort of design principle for very early game production hub area. You would feed in materials that you need here, generally used materials. You grab from the belts and you use this design of two assemblers facing each other with boxes to put stuff in. I actually carry this design principle forward into when I build a bus. So if we have a proper bus, you'll have to bear with me and slightly use your imagination because I don't have the time really to set this up. That's not the point of these videos. But if you imagine this is 4 lanes of iron and, I don't know, say 4 lanes of gears or something like that. So you're probably going to want to make red science in much more volume. And it's going to use inserters and assembly machines. Now, red science, we know, has a production time of 5 seconds, so a typical approach is to have 5 machines making it, which then gives you 1 per second. It doesn't, because the machines never have a production rate of 1, so they're always either slightly slower or slightly faster. But if you build everything to the same spec, as it were, use the same machines, then you'll always be kind of working in ratio, basically. So if we were doing red science, for example, and I use the same design principle where I put the power poles in line with the machines, and that means the power goes outside, and that allows me to avoid, and it's almost a pure aesthetic thing. If we were to build these in a normal sort of a way, or the way most people would do it, they'd end up putting power poles here and here and here and all along the sides, and it uses a lot more power poles, for one thing. But also, I don't like the sort of messiness of this approach, basically. I've obviously done that very messy indeed, but I don't really like that way of building very early game because it's quite sort of messy, it involves a lot more material, and I'm just not a fan. So what I would do instead is I would use this approach. And what we would do is we would perhaps bring the required materials up this side, and then have our output on the other side, and we put inserters so that we can grab stuff, and then we put inserters so they can put stuff going out. That is a very simple design principle. What I usually do is say, if it was a bus, I would be pulling a lane off, for example. These guys use copper, so we'd need to make circuits, and perhaps instead of that we would have, I think I said this was going to be iron, didn't I? But imagine that's copper, and we have a machine here that's making the gears that we need, and we output them like that. I put that power pole in the wrong place, and then say we've got those coming that way. So there you go. So you can see that you're getting the iron you need. The copper's going on that side. What we need to do here, actually, because I messed that up, is it only needs to go on one side of the belt. So this would be, for example, the copper coming off. The iron gear was going on the side. That gives both of these the materials they need. We'll talk about ratios in a different video, and that's them there. Now, one of the things I do is I'll do like reverse busing as well. So if we had some labs here, and we can apply this principle to labs as well. Labs we can just put here, for example, and then we can have the the green science coming up there and going in the labs. And this is one of my other design principles, is that when you're bringing stuff in, then you take stuff out in the opposite direction. Okay, so here we've got copper plate and gear wheels coming in, so they're going up that way, and then the red science is going the other way. The reason for doing that is that if we suddenly decide we want to double our science, so we want to go for 2 a second, then we can very simply add more on. Yeah, and if we wanted to go for 3, then we can add even more on. We might start running into supply issues and things like that, but it's a very simple way of doing it. A lot of players, when they're new, they'll cross belts over. They'll be like, oh, I'm making gear wheels all the way over here, for some other machine. I need them for a bigger red science build, so I'll belt them this way, and I'll send them up here and get the belt the right way around. Send them up here, and then we'll feed them on to this, and I'll turn this round, and I need to put copper on it, so I'll take copper up from here, and we'll grab copper somehow there and stick it on there, and what you end up with, and that's like classic spaghetti, is what results, which is fine. There's nothing wrong with spaghetti building, but you'll find that if you do this type of thing, because you might actually be crossing over, you might be saying, oh, what I actually want to do is I've already got copper plate on this, so I'll put that on there. And suddenly you've caused yourself an expansion problem, because if you want more red science and you build it up here, then how are you going to get it up there, basically? You'd have to, I don't know, split it or reroute it again, or what have you, or maybe that's not enough gears, so you bring in some more gears and you're putting them there, and that's how you end up with the chaotic spaghetti that can get overwhelming. Spaghetti is, ironically, it's something you produce a lot, when you're first playing, and you'll then move away from it because it is confusing. It can make your base overwhelming and messy and difficult for you to progress. Later on, you'll probably embrace spaghetti and you'll be using it all over the place, but it'll be knowing how to use it. That's the sort of difference. And I find that this approach of when you're coming in one direction, you go out in the opposite direction, is a very, very nice, simple design principle that allows you to kind of manage the base.